This session is powered by Sanghi Cement. We are thankful of Sanghi Cement for the same. Please like and share this video so that maximum number of engineers may be benefited. Also, please subscribe to YouTube channel to receive the updates about the future events and to receive notification when we go live. If you want to receive regular updates related to live technical discussions, online courses, etc. through email, then you may register at a link showed on the screen.
Hello. So welcome to this unique live technical discussion series. So at present, I am facing some issue with my mic. So just put it in the chat box whether you are receiving my sound or not. Okay. So welcome to this unique live technical discussion series. And today we are going to talk about a machine foundation. And I have considered it as a part 1. Okay. Because when we talk about machine foundation, it is indeed a very vast subject. And when we floated this event in the social media, we have received very interesting questions. There are almost 300 plus questions we have received for design of machine foundations. Okay, so welcome Raghuram. So thanks for confirming, Yash, that you are receiving the sound. Okay. Okay, so welcome Firoz Khan. Welcome Mohan. Okay, welcome Raghuram for confirming that you are receiving the sound. Okay, thanks Bhavik for confirming. So when we talk about the machine foundation, as I was just telling, it's a very vast subject. And during my career, I had an opportunity for designing a number of challenging, dynamic, vibrate, or let's say the vibrating equipment. We were receiving a number of queries related to machine foundation. So I thought, let's have this kind of a live technical discussion on the machine foundation. And as I was just sharing that we have received more than 300 plus interesting questions related to machine foundations. Yeah. Good evening, VM Rajan, and most welcome. Okay. Thanks, Vijay Kumar. Okay, SK Arjun, fine. So thank you all for confirming that you are receiving my sound, because there is some issue at my end in the microphone. Okay, so before we begin, let me make a couple of announcements, and it is also related to today's technical topic. So as you may be knowing that we conducted a few live technical discussions on this area, which is the interface area between geotechnical and structural engineering. And we are planning to conduct many more sessions which will target on the interface gap area between the geotechnical and the structural engineering. So for that, we have created this Telegram group, and link is flashing on your screen now, which is https t.me/geotech/structure. So you can join this group, and then we all can start interacting within this group related to interface between geotechnical and structural engineering. And from that, we will we'll be picking the points for the discussion, and then we will be having the live technical discussions wherein we will be having group of geotechnical engineers and the structural engineers. Okay, so as far as today's talk is concerned, it is also somewhat related to the geotechnical engineering, which I'll just touch upon whenever we talk about the machine foundations. Right? Okay, so welcome, Dr. Abu Bakr from Kochi, you're most welcome. Okay, welcome. Welcome Chandapara Bharat. Okay, yeah, welcome Nisha. Good afternoon. Okay, okay. So thank you all for joining this live interesting session. So how we'll go about this? First of all, to start with, I'll be sharing the presentation from my side, the quick presentation which I've made based on the queries, whatever I have received, and thereafter we will be going into the question and answering session. But you always feel free to put up as many discussion points, doubts, queries related to the machine foundation, so that we will be taking up during the discussion as and when time permits. Okay. Okay. So. Yes, welcome Abhishek. Okay, so thanks for confirming. Okay, Hizam is telling, give your Telegram group link in the comment. Yeah, it's so again, you can just note it down. I'm just again flashing it on the screen. Please note it down. This is the group for interfacing between geotechnical and structural engineers. And then whatever doubts, queries, points we are discussing in the group, from that we will be arranging the live technical discussions on those areas. So let's say if you're interested, you can join this group. Okay. Okay. So let us begin with the small presentation which I have created for the design of machine foundations. Okay, so excited for today as always. Yeah, we are going to a very interesting and very exciting discussion. Yeah, yes, good afternoon, Abhishek Singh. So let me share the screen now for the presentation. Yeah. Okay. Okay. So as we were just talking before a few minutes, that whenever we talk about machine foundations, then it is indeed a very huge area, right? So that's why I have divided this talk into the several parts, and then we will see how it can be taken forward based on the interest of all. So today's discussion, that's why I have named it as a part 1. Okay. So the questions which we have received through the registration form. So I've just tried to summarize few of them. The questions were like what is the importance of the machine foundation? What are the kind of interfacing required with the equipment manufacturer? What are the preliminary sizing criteria? What are modeling criteria for dynamic analysis? What are the dynamic properties for the analysis? What are the soil dynamics involved whenever we talk about machine foundation? What is resonance? And what is dynamic analysis, etc., etc. So many questions were there. So out of that, I picked up few questions here, and that for those questions we will be talking in general terms today in this short document. And please feel free to share any kind of a discussion points, doubts, queries into the chat box anytime, and then we'll be taking it after completing this presentation. So based on the queries, I have divided, or rather I have created this presentation which is focusing for the heavy vibrating rotating equipment. Let's say the turbo generator foundation, which is greater than 100 megawatts, and it is medium to high speed. and that medium to high speed is defined in IS 2974 Part 3. So whenever we say medium speed, that means the speed of the equipment is, let's say, from the 25 CPS to 50 CPS. And whenever we say high speed machine, then that speed is greater than or equal to 50 CPS. So in this entire talk, in this first part, we are going to focus on the equipment, kind of a turbo generator foundation, which is greater than 100 megawatt. And the speed of the equipment is, let's say, in the range of medium to high speed. So when we fix this criteria, then for our discussion, IS 2974 Part 3 is applicable. So as you may be knowing, in IS 2974, there are several parts. And out of that, IS 2974 Part 3 is applicable to this kind of equipment, which we have just narrated on this document. And one more thing, we will be talking about tabletop foundation, or let's say the framed foundation in this entire talk. Okay. So what is tabletop foundation? Let's say if you do not know, I have just taken one snap here. So in case of a tabletop foundation, we will be having this three kind of elements. So first of all, there is a top deck, and then there is a column, and then those columns are supported on a raft foundation. So this kind of foundation is known as a tabletop foundation, or let us say the framed foundation. So our entire talk is let's say will be focusing on this kind of a tabletop foundation, which is supporting let's say the equipment which is having more than 100 megawatt of capacity, and the speed of equipment is let's say medium to high speed. Okay. Okay, so let's say the first very basic question which we received, that what is the importance of the machine foundation? So always I consider the importance of machine foundation from these two topics. First of all, it is the cost, and second is the design complexity. So firstly, let us talk about cost. So whenever we talk cost of the machine foundation, then actually the cost of machine foundation is very, very small as compared to the equipment which it is supporting. And in the another scenario, let's say if something happens to the let's say the foundation which is supporting the machine, then there could be the loss of crores and crores of rupees, or let's say the loss of major revenue because of the outages which will occur into the industry. So that's why the design of a foundation for this vibrating equipment is very, very critical. Okay. Second thing is the design complexity. So let's say if we talk about a foundation for a static equipment, that means let's say the load is stationary. So in that case, we can say that whenever we will be increasing the size of the foundation, our foundation will become safe. But it is not true for the design of a machine foundation, let's say, which is having the vibrating equipment. So let's say by increasing the size, our foundation may become safe or it may become unsafe, because by increasing the sizes of the foundation, it may happen that we may get closer to the operating frequency of the machine. And because of that, the amplitude could increase from the permissible limits and it may become unsafe. So this is the major design complexity involved in the machine foundation. So merely by increasing the size of foundation, we cannot say that it is safe. Second most important part is that whenever the equipment will be placed on the foundation, then from that point onwards, the sustained loading will be applied on that foundation. That means the load application will start from the 0 day after installation of the machine, and that loading cycle will continue to apply in a cyclic nature for, let's say, for the life cycle of the entire plant. So it's not like a kind of earthquake load which may come or may not come during the, let's say, the service life of the structure. It is the sustained load which will start from the 0 day of the design of the machine foundation, and it will stay there up to, let's say, up to the operation of the plant, up till its life cycle. And one more thing regarding the design complexity is very high interfacing is required with geotechnical consultants as well as with the equipment manufacturer. Okay. So this is the importance of the machine foundation in my point of view. Okay. So what is the basic requirement? That was also one of the point somebody mentioned, that what is the basic requirement whenever we are designing the machine foundation. So for heavy machinery foundation with the rotating masses, it requires that the whatever support system we provide that can resist the dynamic forces which are generated from the machine, which are ultimately resulting in the vibrations. And whenever this vibration exceeds then the permissible limits, then it could be detrimental to the machinery itself. The machine itself could be damaged because of the excessive vibration. Even it's the entire support system of the machine could be also damaged. And also, let's say, if there are any operating personals working around the machines, those persons could be also affected by the vibration. So that's why the vibration has to be limited within the permissible limit whenever we are designing the machine foundations for a heavy equipment. So as we just talked about that, there is very high interfacing which is required. So always I take up this kind of a diagram whenever I am talking about machine foundation, or whenever I am interacting with the equipment manufacturer or the geotechnical engineer. Now this is very interesting figure for me. See, what we can see in this figure, on the central part, there is a structural engineer who is designing this tabletop foundation or a framed foundation. Above that, there is an equipment manufacturer who is designing the vibrating equipment, and then he is passing on all the load data and all necessary information to the structural engineer. And at the bottom of the foundation, there is a geotechnical engineer who is defining the soil properties, the dynamic soil properties, etc. That is given. Now, in no project, see, geotechnical engineer is going to interact with the equipment manufacturer, right? It's only structural engineer who will have to do interface with the equipment manufacturer and the geotechnical engineer. And I always used to say that whenever we talk about this RCC structure, what we see on the screen, which is having, let's say, the elevated slab, column, and mat, then for these RCC structure, if we consider it is a stand-alone structure, then very easily we can determine its stiffness, its dynamic properties, or let's say it is having the closed form solutions. There are no ambiguities at all if it is an isolated RCC structure of let's say, of this proportion, or let's say of this geometry. But the complications start getting involved when we are placing the machine over it, and each equipment manufacturer is having their own way of giving the loading data, or they have their own way of let's say preparing the load data table. So this is one thing I observed while working on a different machine foundation, that the load data, or let's say the type of load data, or let's say the extent of load data, vary from the manufacturer to manufacturer. So that was the first, that is the first activity which we need to carry out, is to study the drawing of the equipment manufacturer. And at least I'm used to spend at least, let's say, the time of 2 to 3 days and listing down all queries, doubts, whatever we have with respect to that equipment load data. And then those all details are being marked on the drawing, and then those are being sent to the manufacturer for the clarification. And on the bottom of the foundation, there is a geotechnical engineer. So there also there are a lot of uncertainties that I will again touch upon that area as and when we move into the presentation. But this is the way I see this tabletop foundation, or let's say this machine foundation, wherein there is a structural engineer who has to interface with the equipment manufacturer, geotechnical engineer, as well as structural engineer will have to do the interface with the construction engineer also, because construction of this foundation is also bringing certain kind of challenges. So that close interface is also required. So if we talk about inputs from the equipment manufacturer, that was one of the question, that what are the kind of inputs we are getting from the equipment manufacturer. So here I have just tried to summarize the list or the details which will be generally included in the equipment manufacturer detailed general arrangement or the load detail drawing. And if any detail is not there, then always we put up a question, we discuss with them, okay? And if it is to be considered, then we include it. So let's quickly see one by one what are the basic details which will be included. So firstly, equipment base plate dimensions naturally. So overall base plate dimension has to be included. The empty weight of the equipment will be included. Then operating weight of the components, including their CG locations, needs to be included, so that we can calculate the CG of the foundation, as well as we can calculate CG of the machine, and then we can calculate the eccentricity. Then if there is a presence of any thermal load because of the operating condition, or let's say let's say because of the functioning of the equipment, that should be included. A piping load if any. Seismic load also sometimes it is given, sometimes we calculate based on the mass of the equipment. Anchor bolt and pocket details needs to be studied one by one, and that's very important and very critical area, because ultimately the machine has to be fixed properly. So for that, whenever we prepare the general arrangement drawing based on the manufacturer load data, then again we send them for their approval, so that wherein they can check again all pockets, anchor bolt details, etc., only from the general arrangement perspective, so that there is no mismatch or there is no miscommunication happening just in a process of reading the drawing, so that we do not get the bigger surprises at the site, because repairing those kind of details on the site is very costly affair, and at the same time it will damage the foundation to a great extent. So that's why that's very important point. And of course, grout thickness and the grout type is also a very much important parameter that will be included in the manufacturer's drawing, and if it's not included, then we discuss with them for including it. So these all were kind of we can say the static load data, or general arrangement details and the static load data. And again, all the details related to the dynamic properties of the equipment will be also included, like let's say the operating speed of the machine. Now sometimes the machine is having variable frequency, so that is also mentioned on the drawing. So variable frequency meaning the equipment may be operated, let's say, in a range of frequency, and whenever there is a range of frequency, then it is very critical for the design of foundation, because then we have to get out that from that complete range, okay, instead of having a single value. Also, there is one input which is mentioned in a few of the drawing, which is the critical speed of machine. So critical speed of machine is this is the critical speed at which machine will vibrate or machine will be having resonance within itself. So this is not the speed at which machine will operate, but this is the speed at which the machine itself will be having resonance within itself. Then there are dynamic loads under operating condition. So based on the unbalanced rotating mass, the dynamic loads will be generated, and those dynamic loads will be mentioned in the drawing for the operating load condition. After that, the phase difference between equipment is very important. Let's say if there is any phase difference, then that will be identified. Now, what is the phase difference? The phase difference meaning let's say if there are 2 or 3 equipment supported on the same deck slab, and now if those equipment is having a different phase angle, that means they will get a peak value at a different time. That means all the machines will not be getting a peak value at a similar time. So because of that, it may happen that one machine is exerting force in, let's say, in a plus x direction. At the same time, another machine will be producing force in minus x direction, and that depends upon that what is the phase angle there, and because of that, it may cause a twisting of the foundation. So the phase angle is very important, phase difference is very important, and that we should also put very carefully into the computer analysis. Thereafter, there is a abnormal load conditions. Now, abnormal load conditions like such as the short circuit loading, blade failure. So these are a kind of a condition which are very rare to occur. But what will happen? Let's say if there is a one blade which is failed. Now the high speed machine is rotating and one blade is failed. So at that time there will be a sudden jerk on the machine foundation. So so the manufacturer will identify the equivalent static load considering that abnormal condition, and of course whenever this let's say the blade failure will occur, then there will be sensor and etc in the equipment, so that equipment is not going to run for the larger time. Just after, let's say, few seconds, it will come to the still stand condition. So based on that, the equivalent static load is identified for the blade failure condition. Now, similarly, for the short circuit load case also, it is again a temporary case. So for this short circuit load case also, the equivalent static load is identified in the drawings. Okay. Thereafter, there is a very important point which I have mentioned, which is the allowable amplitude. Now that amplitude is single or peak to peak. So first of all, now there are 2 important points in this area. First of all, we always ask for the maximum allowable amplitude at top of the foundation, because let's say we are not modeling the equipment. Now generally I have seen that the equipment manufacturer tend to give the permissible amplitude data at the shaft location, at the shaft of the machine. Now if it is given at a certain height, then we will have to make certain pro rata calculations and etc. So instead of that, we always ask that please give what is the maximum permissible amplitude at top of the foundation. And if it's not clarified in the drawing, that then we ask that we understand that it is at the top of the foundation, and if it is not at top of the foundation, then please provide the relevant permissible amplitude. One more area in this, which is the single or peak to peak. Now that is very important area. I have seen the difference, or rather the different way these amplitudes are being given in the equipment manufacturer drawing. So that I'll showcase in the next slide. And also there is allowable velocity criteria sometimes, then it is mentioned in the drawing. Okay, so these are few of the information related to the dynamic characteristics of the equipment, which is mentioned in the drawing. Now let's spare a couple of minutes on these related to the single or peak to peak foundation. Now, whenever we are carrying out the computer analysis for this kind of, let's say, the tabletop foundation, and then when we derive the amplitudes, so those amplitudes are always that amplitude is only of one side, which is shown on the screen on the left hand side, which is mentioned as an amplitude. That's what we get as an output of the computer. Now, sometimes vendor or product manufacturer or let's say the equipment manufacturer, they mention the permissible amplitude as peak to peak. So whenever it is mentioned as a peak to peak, then for our design, we will have to divide that amplitude by 2. So if nothing is mentioned in the equipment manufacturer's drawing, then always we ask them that whether it is a single or peak to peak, please clarify. Or let's say we say that we understand that this is a single amplitude. Okay. So permissible amplitude generally for this the kind of equipment we are discussing, for almost I think all the cases it is defined, very clearly mentioned in their drawing. But let's say if it is not mentioned on that drawing, then we can refer the chart which is given in the IS 2974 for the different level as per our requirement. Okay. Now, that was also one of the question which was asked, that how to calculate the dynamic unbalanced load, let's say if it is not given by the equipment manufacturer. So that dynamic unbalanced load may be calculated using this ACI 351 3R04, and also in IS 2974 part 3 also the same kind of methodology which is given. So always for let's say for working out dynamic unbalanced load for any machines, the balance quality guide is very important. So what we see on the screen on the left hand side, the first column is showing the balance quality guide. Now the equipment which we are talking right now, that will fall generally in the balance quality guide of G 2.5. So once we identify the G 2.5, and as I recollect, IS 2974 is telling that you consider one class above so that we get higher forces. So we need to consider, let's say, G 6.3. So when we consider balance quality guide as a G 6.3, then we get the product of eccentricity into frequency. That is the second column. And after getting that value, then we can calculate the unbalanced force using the formula which is given on the right hand side of the page. And similar formula or similar methodology is also given in IS 2974, so that you can refer if you have any doubt. Yeah, there were few questions related to preliminary sizing criteria and model for the dynamic analysis. So if we talk about the preliminary sizing criteria, here I have summarized a few of the criteria. Now, why preliminary sizing criteria are very important for this kind of a foundation, because there will be a lot of trial and errors will be involved if we have not picked up appropriate foundation size from the beginning. So so there are certain criterias are given. Based on that, at least we can start. Of course, as and when we progress in our trial and error, we can optimize, we can reduce, and then we can customize the foundation as per our requirement. But just to start with, as a first point, these are the few points based on that the preliminary sizing may be done. So first of all, first point is that depth of the base raft in meter shall be at least 0.6 plus L by 30 meter. So what is the overall intent of this this 0.6 plus L by 30? So in my opinion, just to consider it as a rigid plate instead of behaving it as a flexible plate. And when we will see the dimensions of the column for this kind of foundation, that will go in range of, let's say, 1 meter to 1.2 meter. Thickness of deck slab will be also, let's say, in range of 1.2 1.5 meter. So similarly, the raft thickness will be also, let's say, in range of 1.2 1.5 meter. And there are a few more criteria like mass of the foundation by mass of the machine, as well as mass of the top half of the foundation divided by mass of machine. So with these several criteria, we design, or rather we do the preliminary sizing, considering the functional requirements as well as the data which has been provided by the equipment manufacturer. So at a first step, for overall stability and rigidity, we consider the bearing pressure within 60% of allowable bearing capacity of vertical static loads alone. And there shall be no tension condition under application of vertical plus lateral loads. That is, entire footing area shall be in contact with the soil. So so those were a few preliminary sizing criteria. Based on that, we say consider preliminary sizing. Now the most interesting question comes up: what is the most appropriate model for the dynamic analysis? So here I have given three options: option 1, option 2, option 3. So let us see all three options briefly. So option 1, when we talk about, in that top slab is modeled with the plate elements. All columns are modeled using beam elements, and support condition is fixed at the bottom. Okay, so that is the option number 1. In the option number 2, it is said that the top slab is modeled using solid elements, then columns using beam elements, and then bottom slab is modeled in this case. So in the first case, no bottom slab was modeled. So instead of that, directly fixed support was applied in the first model. But in the second option, the bottom slab is modeled again with the solid elements, and then support condition is springs at the bottom. So the option 2, you could see it is mentioned as an incorrect approach, because whenever we talk about the solid elements, then the solid element, in the solid element, each element, or rather, sorry, each node is having only 3 degrees of freedom. That is 3 translational degrees of freedom only. Whereas our beam elements, which we have modeled as a column, it is having 6 degrees of freedom. So there will be a compatibility issue, and that's why option number 2 is incorrect approach. So let us see what is the option number 3, which I have mentioned. So in option number 3, top slab is modeled using solid elements, columns are modeled using solid elements, and the bottom slab is again modeled using solid elements. and support condition is springs at bottom. And according to me, the option number 3 is the preferred approach. So firstly, the effect of or let's say the problem of incompatibility will be removed, because we are using now single type of element throughout the structure. And second thing, now when we compare option number 3 to option number 1, so after working out several examples, I have seen that in the option number 3 we get a higher frequency, higher natural frequency in the first mode. So what is the reason? Let's say whenever we talk about the dimension of 1.5 meter or 1.2 meter, and when we actually model using the 3D solid elements, then the stiffness whatever we get from those solid elements is definitely higher than the single line beam element which is in the model in the computer. So I have given some numbers that how much differences I was observing, and why it is preferred option for me, the option number 3, because by using solid elements, my natural frequency in the first mode will increase. Okay, so what will happen? I am actually going more towards the operating frequency, because when we talk about these medium to high speed rotating equipment, let's say which is having a frequency from 25 cps to 50 cps. Now when we talk about this tabletop foundation, the first natural frequency what we will get out of our analysis, that will be, let's say, in range of 5 cps, or let's say the 8 cps for example. So whenever we are going ahead with the option 3, it is more appropriate according to me, because we are going towards the operating frequency. Okay. So now one more question is, which was asked by a few engineers, whether bottom slab to be modeled or not. So according to me, the bottom slab should be modeled to consider the effect of soil as a supporting medium. And whenever we will model the bottom slab, then the mass of soil can be considered for the dynamic analysis, because the soil which is there on the bottom slab, that will also contribute towards the mass of entire system. So let's say if we consider it as a column having the fixed support, we won't be able to consider that additional mass. And also there is a second point, like also absence of bottom slab and provision of fixed or pin support at the end of columns will lead to very, very high stiffness in a vertical direction. And correspondingly, we will get very high natural frequency in the vertical direction. So from these 3 reasons, I would suggest that we should model the bottom slab. So with this, now we can summarize the preferred option for modeling. In my opinion, all elements for this kind of foundation can be modeled using solid elements, and spring supports at bottom face of the foundation. And this model is relatively stiffer than the other models by plate/beam elements for the same foundation, as we just discussed. And variation in the natural frequencies observed were in the range of 20 to 30% for the problems for which I made the comparison. And this option is preferred since mass of the bottom foundation will be also considered along with the mass of soil, and also actual stiffness provided by soil will be considered in this analysis. And as we just discussed in the previous slide, that due to unique type of elements, there is no issue related to compatibility. Okay. Okay, so then there were a few questions related to dynamic properties for analysis and soil dynamics. So I have gathered a few details for it. So firstly, whenever we talk about the mass definition, then all masses shall be applied in x, y, and z directions. And always I put up a static check. Let's say after providing all masses in the foundation, then we consider a static check to verify whether the applied mass value is correct or not. Because I've seen in a number of problems that, let's say, out of enthusiasm, let's say the very high model is created, and then all kind of dynamic analysis, everything is performed, and then at the end of end up after performing few iterations, let's say for 4 or 5 days, it was observed that static check itself is not correct. That means mass definition was not correct, and there was a lot of repetition. So always that's a very important point which I am suggesting, that static check shall be done before we move for the further dynamic analysis. And one more thing, the dynamic modulus of elasticity shall be considered, and range is mentioned in IS 2974. So that is actually, or we can say generally, it is higher by 20% approximately as compared to the static modulus of elasticity. And as we will increase the modulus of elasticity, again we are going towards the operating speed of the equipment. That's why it is very critical and we should consider it. One more thing about damping. So IS 2974 part 3 is suggesting that the damping shall be assumed to be 2% of critical damping under operating loads, and a higher damping of 5% may be used under emergency loads like blade failure, short circuit, bearing failure, etc. Meaning, for all operating load cases, the damping shall be considered only 2%, not more than that. And why it is 2%? Because the damping is playing very vital role when we are getting, let's say, in the resonance zone, or let's say near to the resonance zone. Hence, in case of a likely condition of resonance, the damping value shall be judiciously decided. And that's why probably 2974 is restricting the damping value to only 2% for dynamic analysis. Okay, so we have talked about equipment manufacturer data. We have talked about modeling. We have also talked about damping and, let's say, the preliminary sizing, etc. Now let's talk a little bit about these soil dynamics. So for deriving the dynamic properties of soil, the dynamic shear modulus G needs to be evaluated. So dynamic shear modulus G is the most important soil parameter which is influencing the dynamic behavior of the soil foundation system. And together with the Poisson's ratio, it is used to calculate the soil impedance, or let's say the soil spring values. So here on the screen, you can see certain values of Poisson's ratio for the different kind of a soil, which is given in the IS 5249. Now, it's a very interesting slide that, let's say, there may be a range of G value to be considered due to uncertainty in determination of this value. So as we just discussed, that the Poisson's ratio and the dynamic shear modulus are the very important parameter, but this parameter may be significantly affected by water table variation. So always it is prudent to consider the range of geotechnical stiffness in consultation with the geotechnical engineer. So when we say the range of geotechnical stiffness, that means we may consider, let's say, whatever G value we are getting, that value we will multiply with 1.75 so we will get a lower stiffness, as well as we will multiply that factor by 1.5. So that's a variation from, let's say, the 0.75 to 1.5. Now those values we should decide in consultation with the geotechnical engineer, that what is the appropriate range which should be considered for the dynamic analysis of the foundation. Now here the most important part is that here we are talking about dynamic analysis of the machine foundation. So that's why there will be there will be so many a number of iterations which will be required if we will consider this range of stiffness, because it may happen that in a certain value of the soil spring values we may be getting too close to the operating frequency. Then that is the most critical condition for us. So that critical condition needs to be evaluated, and then it needs to be further investigated for the free and the forced vibration. So that we will talk in a subsequent slides. So in short, it is prudent to consider the range of geotechnical stiffness instead of considering just a single value. One more part, due to embedment of the foundation, always the foundation will be embedded in the soil, and because of that the soil's spring stiffness will increase to a certain extent, and ACI 351 is suggesting certain formulas for the same, so it may be referred. And IS 5249 can be referred for determination of the dynamic properties of soil method of test. Now this is again very important slide according to me. So it is talking about correlation to other soil properties. So let's say now if we do not have a proper soil investigation wherein the dynamic soil properties are not defined, so always there is an inclination for considering the dynamic soil properties based on the correlation. Now always I am putting the statement that the engineer should be careful when using any correlation method for this kind of a foundation what we are discussing, because these correlation methods are generally, we can say, they are least accurate methods, and the most appropriate time to use this least accurate method is let's say only for the purpose of preliminary sizing. But for all final design, drawing or calculations, we must use the refined value whatever we get from the geotechnical investigation report. And let's say if we are considering again the correlation to the other soil properties, then that also should be considered as a providing a range of possible values and not providing a single exact value. Okay, then there are few questions related to the dynamic analysis. That what are the software which are used? So according to me, these are the software. GT Studio SAP 2000 NC STED can be used for this kind of analysis. And whenever we talk about dynamic analysis, it can be divided in two parts. So one is the free vibration, and other second is the forced vibration. So always we must perform a free vibration first before the force vibration. So what information we will get out of the free vibration? So out of free vibration, we'll be getting the information related to the natural frequencies, mode shapes, mass participation, etc. So our first check will be that we will be comparing the natural frequencies of the foundation along with the forcing frequencies of the machine. And at least a 20% difference should be there between the forcing frequency and the natural frequency. And we must consider at least 95% of mass participation. Because see what will happen, interestingly, whenever we get into the mode shapes, then the higher mode shapes will be having the higher frequencies, Now, as we go down, the frequency values will increase, and it is possible that in the certain higher mode, it is getting very close to the operating frequency. But at that time, as and when we go down, the mass participation is decreasing. So that's why I have written a third line, that at least the mode shapes having mass participation less than 5% may be ignored. But it is possible that, let's say, our first, second, third mode, or let's say up to fourth, fifth, or our primary modes are quite away from the operating speed. But the higher modes may get very, very close to this operating speed. And there were few incidents in which the number of iterations were happened to remove even that higher modes, because it was almost matching, and then that was creating problem in terms of amplitude. Okay. So these are the kind of information which we'll get out of free vibration analysis. So after performing free vibration analysis, we will perform forced vibration analysis. So in case of forced vibration analysis, the dynamic force will be applied using time history functions. Now, why it is required to apply the load using time history functions, that I have mentioned in the second para. It is preferred to use a time history analysis so that the transient response can be considered. So what is transient response? We will just see in the next slide. And in harmonic analysis, only steady state response will be considered. So let us try to see what is the transient response and the steady state response. So here I have just taken the graph of, let's say, from the one of the design of the tabletop foundation. So here we see the variation of the amplitude with respect to the time. Now, as we see in the initial part of the period, wherein we could see that the amplitudes are abrupt in nature, and they are getting value of 2.4 micron, 2.23 micron, and then after certain time that values are reducing, and then slowly and gradually it is becoming less than 1 micron. Okay. So whenever it is becoming less than 1 micron, that is known as a steady state approach. And the zone of 2.4 and 2.23 micron is considered as a transient response. So what will happen that whenever we start the machine, so at that time machine is not going to attain the speed immediately from, let's say, from the 0 to this higher frequency though. So that's why we will get certain peak value, or let's say the vibration could be higher in the initial period of the time also. So to investigate that, the transient analysis or the transient response needs to be captured. So that response can be captured only through time history functions. So right now what we see on the screen is the time history plot of one of the joint after performing the forced vibration analysis into the computer. And if we do not consider it as a time history analysis, and if we perform only harmonic analysis, then in that case we will be only getting the response which is less than 1 micron in the computer output, and that is going to be the single value what we will get. Okay. So with that harmonic analysis, we won't be able to capture the peak value what we are getting in the transient response. So that's why time history functions should be considered for the dynamic analysis for the forced vibration. Okay. Okay, so that's all. Quickly, I have tried to summarize a few points, whatever you shared through the registration form. So as a concluding remark, high interfacing is required with the equipment manufacturer and geotechnical engineer and the other adjacent facilities. So wherever we are putting this vibrating equipment foundation, even interface is required with the surrounding foundations also. So always we should take care that the foundation is having at least air gap, or let's say the proper sand filling is also placed, so that the proper gap is ensured with the adjacent foundations, so that the vibration from this tabletop foundation, or let's say the vibrating equipment foundation, shall not transfer to the other adjoining foundations. Second point, the range of geotechnical stiffness shall be considered for dynamic analysis in consultation with the geotechnical engineer. Then proper modeling of mass and stiffness to be done for getting reasonably correct results. Soil stiffness must be considered in dynamic analysis according to me. Transient response shall be considered, as we just discussed in the previous slide. And over and above this, that engineering judgment shall be utilized instead of merely dependence on the results from the software. So I'll tell you, I have created so many study models for experimentation purpose to see how software is giving output in a different conditions. And from that, I created my own process of interpretation, my own process of modeling, my own process of do's and don'ts in a different software. So the point which I just want to highlight on this point, that we should not depend only on the software. Engineering judgment must be utilized for this kind of a foundation. And proper reinforcement detailing shall be done. It's very important. And during reinforcement, detailing the constructability aspect must be taken care, because it's this kind of foundation is having very large dimensions. So the reinforcement, detailing, and everything needs to be done very carefully. And it is recommended, this is the last point which I have mentioned, that it is recommended to collect the data related to the actual vibration versus the estimated vibration during the design cycle, like whatever, let's say, computer analysis we have done, and then whatever vibrations we are getting. So those vibration data can be captured, and then it can be compared with the actual vibration of the machine. Then that kind of a database will be extremely useful for the future designs. Okay. Okay, so these are the few references which I just quoted in the document. So ACI 351.3R04 you can refer, which is foundation for dynamic equipment. Then IS 2974 for design and construction of machine foundations, and IS 5249 for determination of dynamic properties of soil. Okay, so thank you all for participation, and now we are opening this session for question and answer. So you can put up few questions, whatever questions, doubt, queries you have in the chat box, and then we will take up a few questions for the discussion. Okay, so let me. Okay, Meghna Raut is telling, very good topic, thank you. Absar Khan is telling, main problem is dynamic vibration of equipment foundation. Yes. Yes, Patel is telling, in this diagram the equipment would be placed on the elevated slab. Yes, the equipment will be placed on that elevated slab. So why we are providing this kind of foundations? It may be provided for, let's say, 2-3 scenarios. For example, let us say if we have a kind of a process requirement wherein the pipes from the equipment needs to be transferred from the let's say from the bottom of the equipment, and then that pipe is coming out of the, let's say, from the foundation area. So for that we need to create a hollow area, so from where the old piping can be done below the equipment. And sometime to meet a dynamic characteristics, we are creating this kind of foundation. Let's say for some cases our frequencies of let's say the operating frequency and the foundation frequency, if we are considering our foundation as a solid block, and then let us say if the frequencies are matching, then this is one of the option by which we can create it in a framed foundation, so that our foundation will become flexible, and there will be a sufficient gap between the operating frequency and the natural frequency. Okay, Nikita is asking, who will give the top level of slab or bottom level of equipment? Okay, so these details will be finalized by from the process requirement. So process requirement, this equipment level will be identified, and that will be conveyed to the equipment manufacturer, and the same level will be considered for the further design, but it will be defined from the process requirement. Okay. So it will determine the height of foundation. Yes, so based on that the height of foundation will be determined. So that bottom of the equipment or the top of the foundation is always based on the process requirement. Okay, interface between foundation bottom and the mother slab. I think we touched upon this area, right? If you have any additional questions on this, please feel free to share. Okay, Samir is telling it was my bachelor's project. Yes, yes, good, Samir. Okay, Bhavik is telling good session. Thank you, Bhavik. Chetan is telling excellent session. Yes, thanks a lot, Chetan. Okay, Nikita is asking what is the difference in operating speed and critical speed and how it is impacting the design. So, see that's what we touched upon. Whenever we talk about the operating speed, then operating speed is the speed, as we all know, that is the speed at which the machine will operate in let's say in all normal conditions. Now, according to me, the critical speed is the speed at which the equipment itself will be having a resonance within it, or let's say if our foundation is vibrating at that frequency, then the machine could be damaged significantly. So as far as operating speed is concerned, we have to take let's say the difference of 20% from that region, and generally for this critical speed also we consider the difference of 20%. So for us, both the speed will be identical. Like we should have our natural frequencies away from this operating speed as well as from the critical speed. Okay, Abhishek Kumar is telling how to design machine resting directly on the raft. So if you can specify a few more details like weight of the machine, dynamic load, etc. in the chat box, then we can discuss it in a more detail. Abhishek is telling, sir, can you share any reference model and PPT? Okay, so for reference model, you can just get in touch with me. Okay, Rajan VM is telling, in case of machine foundation, reinforcement is provided in all three directions. Is there any minimum reinforcement to be provided specified by the code? So yes, so there is a minimum reinforcement which is defined by the code for all different kind of foundations, and generally speaking, for all the foundations, we will be having minimum reinforcement only because the sizes of the elements are such large, so that our elements, or let's say they are not at all critical in the strength. And because of that, the whatever reinforcement we get from the strength requirement, that is even lesser than the minimum in all the cases. Generally, that's what I have found out. So in all such cases, the minimum reinforcement which is specified in IS 2974 in the relevant code will be applicable. Okay, Jaideep is telling, I think plate element is better for reinforcement calculation from plate stresses instead of solid elements. Yes, absolutely right. That's perfectly right point you have said. So, so what we were doing, interestingly, for dynamic analysis, we were creating a 3D solid element, the model which I just showed on the screen. Then, when it came to the static analysis for calculating the reinforcement, we were creating another model from the point except the point which you have identified, because calculating the reinforcement from the solid element is very difficult. So we were creating another model just only for a static check, or rather let us say for the static design of the foundation. And at that time we were modeling it as a plate elements, but after modeling all the elements, generally see it was coming out that all elements were coming into the requirement of the minimum reinforcement. Siva is asking, how are we checking the strength of concrete or steel reinforcement for the fatigue? And that's a good question. See, for the fatigue in IS 2974, the factor is given as a 2 for the kind of a foundation we are discussing. So that factor needs to be applied while doing the static design. Khyati is telling, sir, which procedure gives proper results, providing springs or soil modeling? So, according to me, see, our whatever software we have, it would give the appropriate result with the springs. So generally, modeling of the soil, at least I have not tried in any of the project. We were only modeling it with the springs only. Okay, Suresh Kumar is telling, one of our turbine supplier is not in a position to issue amplitude in microns or mm. They have mentioned as VRMS as 1 mm per second. Yeah, so that's the velocity criteria they have mentioned, which is 1 mm per second. And whenever you will calculate, or rather whenever you will go for the forced vibration analysis, you will be able to calculate this velocity. You will be able to take the graph of the displacement, velocity, as well as the acceleration. Okay. And after getting that graph from this forced vibration analysis, you need to check that your this VRMS is less than 1 mm per second. Okay, Sandesh is telling minimum reinforcement for silent type DG foundation as per code. Silent type DG foundation. I'm not getting your question clearly. Can you please elaborate it with a bit more detail? Okay, Chetan Prakash is telling that on behalf of Sanghi Cement, we thank all the participants and special thanks to Bhavin sir for sharing excellent knowledge. Regards, Chetan Prakash Verma, Head Technical Services. Most welcome. Thanks a lot, Chetan ji, for this message. Okay, Rajan VM is telling, if the water table is found nearer to ground level, is there any precaution to be taken to provide a machine foundation? Yeah. For the water table, I just touched upon one area that that the soil spring stiffness is will have one impact. So that's why, generally speaking, we should consider a range of geotechnical stiffness. That is one area. And if there is a water table we need to take care that there is no uplift in the foundation, or let's say whenever we are checking the foundation, no part of the foundation should be getting uplifted. That means entire foundation should be in a contact with the soil. Okay, yeah, most welcome, Suresh Kumar. Okay, so thank you all for participation and for raising very interesting point through registration form. So from that, we could develop this kind of a presentation. Okay, so now